All right, here's a lesson on zeros, multiplicity, things like that. So let's start with some vocabulary and then we'll practice. So the x-intercepts of a function are also called zeros. They're also called roots as well. A polynomial function of degree n can have at most n real zeros. So the exponent, the greatest exponent, tells you that's as many zeros as are defined. So an even degree polynomial has an even number of real zeros, and an odd one has an odd number of real zeros. Linear factors and solutions. So the solutions to the equation y equals 0 are the zeros of the function. They are also called roots. We were talking about that. So if you take the equation equal to 0, so if you take out the y, another way of writing this is if you take the function equal to 0 and solve for x. That's how you find the zeros. If x equals c is a solution to the equation, then x subtract c is a factor of the polynomial. We're going to understand that zeros and factors are inverses of each other. So if one is positive, the other is negative, and vice versa. As we practice, that will become intuitive, I think. Linear factors can be found by factoring the polynomial. So look at this example, and the question is, what are the linear factors of it? So linear just means that when you factor, each factor has an exponent of 1. So how would I factor this in terms of what you see? So the first thing I notice is that all three terms have an x in common. So I'm going to factor out an x. And when I factor, it means you divide out. And what's left over is what we need to write down after you divide. Now when you divide, know that you're subtracting exponents. So if I divide out an x, I'm subtracting 1. So it's x squared, subtract 1, so it's just 5x. So subtracting 1 from the exponent, and then just negative 24 as you factor it out. What's left over? Some of you have been taught to draw a diamond, so I can do that over here. And so you have negative 24 and 5. And you're thinking, what two numbers multiply to 24 and add to 5? Now it's important that 24 is negative. That means you are subtracting to equal 5. So what two numbers multiply to 24 and subtract to equal 5? So that's going to be positive 8 and negative 3. And the reason that 8 is positive is because the larger number needs to be positive to get a positive 5 as an answer. So if I come back here, if we first started with x, and then what was left over we factored out, we said positive 8 and negative 3. Those are the factors. Now, what are the zeros here? Well, for each factor, you'd make it equal to 0 and solve it. So if I take x equal to 0, well, that's the answer. So one answer is 0. If I take the next factor, x plus 8 equal to 0 and solve it, notice you're going to be doing the inverse every time to get x by itself. So the inverse of positive 8 is negative 8. Of negative 3 would be to add 3. And you can see the relationship there, that one is the inverse of the other. All right, find the zeros by factoring. So let's do this together. Step 1, do they have an x in common? Yes. So when you factor out an x, you're left with x squared plus 3x minus 10. You can draw a diamond, and it's negative 10 and 3. What two numbers multiply to negative 10 and add to 3? It's important that 10 is negative, because that tells me I'm subtracting. So the two numbers that are going to work are 5 and 2. And again, the 5 needs to be positive, and the 2 needs to be negative. So 5 take away 2 is 3, and 5 times negative 2 is negative 10. It matches. So when I write this in factored form, I have one factor of x plus 5 and the other of x subtract 2. Now, to solve this, to know what the zeros are, I take each factor and do the inverse. Now, for just x by itself, the inverse of 0 is 0, like it's x equals 0. So, if you don't see adding or subtracting, it's just an x or a monomial in front, just a term, then the answer for the 0 is 0. But the next one's going to be negative 5, and the next one's going to be positive 2. That's the skill we're practicing. Look at the next one. Can we factor it? So step 1 is, do they have an x in common? Yes. So factor out an x, and I got 2x squared minus 5x subtract 3. Now again, I'm going to draw a diamond. It's a little different this time because it's not a simple trinomial. So to factor this, I'm going to go the first times the last. See, a simple trinomial would mean the a, what's with x squared, is just 1. It would just be a 1x squared to factor in front. We have a 2x squared, so that makes it not so simple. So 2 times negative 3 is negative 6, and then negative 5. And then I do exactly what I just did before, meaning what two numbers multiply to negative 6 and add to negative 5. So that's going to be negative 6 and positive 1. So they multiply to negative 6, and they combine to negative 5. I come back here. I have the x in front. Oops. I still have 2x squared, but the negative 5x is going to be replaced. So I'm going to take out the negative 5x and put in negative 6 and positive 1x in its place. Now I'm going to factor by grouping. So I'm going to group the first two terms and see what do the first two terms have in common. So only the first two inside the parentheses. 2 goes into both, and they both have an x in common. So the common factor there is 2x, and then I divide to see what's left over. So 2 divided by 2, and x squared divided by x, I'm left with x. Negative 6 divided by 2 is negative 3, and the x's divide out. The next one, all they have in common, x and negative 3, is a 1. But that 1 is important for our factoring. So they have a 1 in common. So I factor out the 1 in front. Then I notice that they both have a factor in common. And the factor they both have in common is x subtract 3. And then what's left over is what's in front of the factors, which is 2x plus 1. And then you factored it. Now, if I want to know the zeros here, remember x by itself is going to be 0. X subtract 3, change the sign. The inverse of that is positive 3. Now be careful here. 2x plus 1. If I'm going to do the inverse here, it's not only going to be negative 1, but the inverse of multiplying is to divide. It's going to be negative 1/2. In fact, if you took 2x plus 1 equal to 0, you'd have to subtract 1 and divide by 2 to get the answer. Number 3. Notice in this case they do not have an x in common. So instead, it's a trinomial that I'm going to factor as a trinomial. So we have 4 and negative 5. The two numbers that multiply to 4 and add to 5 are negative 1 and negative 4. So negative 1 and negative 4 multiply to 4 and they add to negative 5. So, but instead of using x, because the degree is 4, I'm going to use x squared. So x squared subtract 1, x squared subtract 4. That way when you multiply it, you add the exponents, they actually match. Now what's left over is called difference of squares. Now for a difference of squares, we do the square root of x squared, which is x, and the square root of 1, which is 1, and we do both adding and subtracting. That's called a difference of squares. Same thing here, the square root of x squared and the square root of 4, and it's adding and subtracting. That's a good technique to know, that when you see a binomial subtracting, it's called a difference of squares, that we can take the square root to be able to factor it out. Now the zeros in this case are going to be negative 1, positive 1, negative 2, positive 2. You could also write it this way, as positive of negative 1 and positive and negative 2. This is a shorter form of saying the same thing. 4. Can we factor it? Again, it's a trinomial, so I'm going to start with the trinomial. It's not a simple trinomial, so I'm going to go 9 times 4, which is 36. Negative 37 goes underneath. I need to find the two numbers that match here. So the numbers that match are going to be negative 36 and negative 1. They multiply to positive 36 and they add to negative 37. So we're going to use those. So I'm going to go back into the equation, take out a negative 37 and put in the two new numbers, which is negative 36 x squared and negative 1 x squared. Now we can factor by grouping. So I look at the first two terms. What do they have in common? Well, 9 goes into both, and an x squared. That's what they have in common. Divide out the 9x squared, and you're left with x squared minus 4. Look at the next two terms. Well, the only thing they have in common is a 1, but they could also have a negative 1, and that's the reason I'm going to use negative 1, so that the parentheses will match. So negative x squared divided by negative 1 gives me positive x squared. 4 divided by negative 1 gives me negative 4. And now these factors match. If I took out a positive 1, they wouldn't match and I couldn't do the next step. So the next step is they have an x squared minus 4 in common. What's left over is 9x squared minus 1. Now this again is going to be a difference of squares. So the square root of x squared is x, and the square root of 4 is 2. So x plus 2, x minus 2. The next is also a difference of squares. The square root of 9 and x squared is 3x. The square root of 1 is 1, so one's going to be plus 1, and the other is 3x minus 1. So now when I find the zeros, it's completely factored. We know that factors and zeros are inverses. So the first factor is going to be negative 2, then positive 2. Now this one's a little more challenging. I got to do two steps. So not just negative 1, but divide by 3. Not just positive 1, but divide by 3. And again, you could write these as positive and negative 2 and positive and negative 1/3. All right, turn the page. So again, we're going to find the zeros by factoring. So what I notice here is we don't have a trinomial. So the first thing I'm going to look at is if I can just factor by grouping right away. So if I look at the first two terms, they have an x squared in common. That gives me x plus 5. If I look at the next two terms, they have a negative 9 in common. And when I divide out a negative 9, I get positive 1. And negative divided by negative gives me positive 5. So I can see that they have a x plus 5. That's the common factor. And what's left over is x squared minus 9. X squared subtract 9 is a difference of squares. So one's going to be x plus 3, and the other is x subtract 3, taking the square root. So the zeros then is going to be negative 5 and positive and negative 3. One more time, can you factor by grouping? So what do they have in common? So what number goes into 20 and 12? So that's 4, and they both have an x squared at least in common. So 20 divided by 4 gives me 5x. Negative 12 divided by 4 gives me negative 3. Now, I want these to match. They almost do, but the signs are wrong. So I need to factor out a negative 1 so that the signs match so I can do the next step. So they have a 5x subtract 3 in common, and then you have a 4x squared subtract 1 that's left over. So one last step to completely factor it. Do a difference of squares. So the square root of 4 and x squared is 2x. The square root of 1 is 1, so one's adding and one's subtracting. So now that it's factored, the zeros, be careful. It's not positive 3, it's positive 3 divided by 5. It's not negative 1, it's negative 1 divided by 2. It's not negative 1, it's positive 1 divided by 2. and you have all the zeros. So that's practicing understanding what it means to find the x-intercepts. And a special word for x-intercepts is 0, because what are the numbers when you plug them in give you the answer 0. That's why they're called zeros. 7. A new word here, multiplicity. And another word, and understanding that, is the word multiples. So the multiplicity of 0 is the degree if its corresponding linear factor. So, in other words, how many times does a factor repeat itself? And that's going to be the exponent on the factor, and that's what gives me the multiplicity. So first I get to factor it to understand the multiplicity. So if I factor out an x, I get x squared plus 10x plus 25. If I factor that out, what two numbers multiply to 25? Add to 10. That's 5 and 5. So I'm going to write this function as x, and then I see that I have positive 5 and positive 5. Well, when a factor repeats, I can write that as one factor squared. So now, when there's asking for the zeros, 1 0 is here, that's 0. What's the exponent on the factor? So what exponent is on x that you don't see? It's 1, so we say this has a multiplicity of 1. And again, where did that number come from? The degree, the exponent on the factor. What's the other 0? Well, it's negative 5. But now, what exponent do you see on that factor? How many times does that factor repeat? And it's 2. So negative 5 has a multiplicity of 2. Let's try that again. Can you find the 0 and multiplicity? So for number 8, factor. So I can see that what do they have in common is a negative x squared. That leaves me with x squared. 6 divided by negative 1 is negative 6x. Negative divided by negative gives me positive 9. Then, when I factor this, sometimes when it's simple, we can just do it in our head. What two numbers multiply to 9? And the same two numbers add to negative 6. So you see it's negative 3 and negative 3. So I can write it as negative 3 squared because it repeated. So what are the zeros here? Well, negative x squared is a monomial. That just gives me the answer 0. But what's the exponent on there? And you can see that it has a multiplicity of 2. The next factor is x subtract 3. So the inverse of that is positive 3. And you can see that. What's the exponent? 2. So it also has a multiplicity of 2. Now, why is it important to know the multiplicity? Is it helps us with the graph. So it says write this function in factored form and graph the function, then look at how the multiplicities affect the graph. So first of all, if I factor this, I see that they have an, I'll do it underneath, an x in common, and you have x squared plus 4x plus 4. If I drew a diamond, if I need that to support, that's 4 and 4. What two numbers multiply to 4 and add to 4? It's 2 and 2. So that means this function can be written as x and then x plus 2 squared because the 2 repeated. If you went to Desmos and you did this, can you do that for me? So go to Desmos and then type this in. So what I notice here when I go to Desmos, I'm looking for the turning points. So I see the graph turns here at negative 2, 0. It also turns right here close to 0 or close to negative 1 and negative 1. So it kind of turns here as well. And then it comes up here through 0. So this is what the graph looks like. Notice the degree, the power term is x cubed. It is odd, so they go in opposite directions. It's positive, so the right end goes up and the left end goes down. So you can see the turning points and the intercepts, the zeros. So what do we notice about this? Well, when I looked here, we didn't write it down, but what are the zeros here? So if x is a factor, then the 0 is 0. But what's the exponent on x? So it has a multiplicity of 1. The second one, what's the 0? It's negative 2. But what's the exponent on there? It has a multiplicity of 2. So when the multiplicity is even, so at negative 2 it's even, what did you see happened on the x-axis? And what happens is it creates a turning point. Instead of crossing over the axis, it just touches. So when the multiplicity is even, the graph is touching to the x-axis, but not crossing. It's creating what's called a turning point. How about the other one? When the multiplicity is odd. So notice at 0, we have an odd number for the multiplicity. What happened? Well, it went right through, right? So when the multiplicity is odd, the graph is crossing at the x-axis, at that 0. So when you have an even multiplicity, it's just going to touch. But when there's an odd multiplicity, it's going to cross over. So when we talk about multiplicity, we're going to use the words odd or even when we're there. So here are some examples. They're nicer because they're already factored, at least number 9 is. So because it's factored, all I'm looking at are the exponents and the factors and doing the inverse. So if x subtract 1 is a factor, what's the inverse of that? Well, a 0 must be positive 1. Is the exponent connected to that factor even or odd? It's even. And what does that mean? Well, the effect means it's going to touch the x-axis and not cross over. Look at the next one. Remember, it's not just positive 3, but we have to divide by 2. What's the exponent, even or odd? And what does that mean? Again, it's going to touch the x-axis and not cross over. How about the last one? It's just negative 4. I don't see an exponent on the outside. Well, the exponent you don't see is 1, and 1 is an odd number. So at negative 4, it's going to cross the x-axis. This is going to help us when we're graphing and understanding the graph and the equation, how they relate to each other. Number 10. This is not factored, so we need to factor it. So step 1, what do they all have in common? Well, they at least have an x cubed in common. So I'm going to factor out an x cubed. And what's left over is x squared plus 8x plus 16. This is a simple trinomial. What two numbers multiply to 16? Think. Which of those numbers add to 8? And the answer is it's 4. And it repeats itself. So positive 4 and positive 4. That means we write it as one factor squared. So now it's factored. What are the zeros? Well, in this case, x cubed is a monomial in front. So the 0 is just 0 if you don't see adding or subtracting. What's the exponent? It's 3. And 3 is an odd number. And what does that mean? Well, at 0 then, with an odd multiplicity, with an odd exponent, it means it's going to cross the x-axis. How about the next factor? What's the 0 that comes from that factor? Negative 4. What's the exponent? Is it even or odd? And if it's an even exponent, what's going to happen at negative 4? It's going to touch the x-axis. Turn the page. All right, so that's the lesson, and here's the homework part. So I'll do the homework part in a next video coming up. So the best part would be, of course, if you did the practice first and then turn to the video to see if you needed support from it. All right, Mr. G Math, over now.